From South Bend, Indiana, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
It was just the hype at the time. The way we did our homework to find the right technology for us was to go out and review all the technology that was available and we thought would be relevant to developing nickel titanium.
That was Mohammad Elahinia. Mohammed is currently serving as the Interim Dean of the College of Engineering and was most recently the chair and professor in the Department of Mechanical Engineering, Industrial and Manufacturing Engineering at the University of Toledo. He serves as director of the Dynamic and Smart Systems Laboratory at the University of Toledo and has been on the faculty since 2004. Mohammed graduated from Villanova University with an MS degree and from Virginia Tech with a Ph.D. in Mechanical Engineering, respectively in 2001 and 2004. His research interests are in smart and active materials, and his current research is focused on additive manufacturing of functional materials such as shape memory alloys for aerospace and biomedical applications. Before we get started, head over to www.3degreescompany.com and subscribe to the podcast. Remember, you can listen to the show anywhere you download your podcast, including Spotify, Apple, Amazon, or Stitcher. Also, if you or your company are looking for materials, qualification, or general additive manufacturing support, reach out to the team through our website or via email at info@3degreescompany.com. Thank you so much, Mohammed, for joining the show today. We're excited for the episode. I think I like to start where we do with all our guests and kind of from the very beginning and say, where were you born and what were some of those early memories of either manufacturing or engineering that kind of put you on the path to where you are today?
Sure. I was born in Iran, and early memories, I remember definitely, like many other kids, breaking stuff, sometimes expensive toys. I don't know if it is any indication of interest in engineering, but probably I was curious like any other kid. Growing up, I do remember struggling with math, especially in the high school. I hear other engineers talk about I came to engineering because I was very good at math and physics. I did definitely struggle. I was the first one in my family to complete the high school and definitely the first one to go to college. So part of it is when I reflect back, part of it was I was the first in the family to reach high school. I didn't know any better that I needed to study and spent my time playing outside, as it was the norm back then, to spend as much as time as possible play, and that's what I did. But as I got closer to the end of high school, then our teachers started talking about the next level, which was going to university. And I realized it was the very last year of high school that I realized unless I did some change, I was not going anywhere. So I started spending more time on studying and less time outside the home, and ended up going to an engineering school in Iran. I studied mechanical engineering, and then I worked for a few years before coming to the US in 1999. This August is the 25th anniversary. I came in August of 1999.
Awesome. Congrats. And so when you talk about that transition between kind of high school and university, so you said you studied mechanical engineering.
Mm-hmm.
Did you have an idea of what that meant or a vision for what you wanted to do with that degree or kind of that path of study?
I didn't. The way a university system in Iran worked, and I think still works, is that you sit in an exam and your score more or less tells you what you can afford to go to, not financially, but the ranking more or less dictates. The familiarity I had with mechanical engineering was through two sources. One is a neighbor had started studying mechanical engineering. So when the time came for us to complete the sheet and for me to choose where to go to school, he was influential and instrumental. But also, I had a physics teacher in the last year of high school, and the examples he would bring was many of them was from a successful mechanical engineer. So that was these were the two main motivation. And I mentioned I did struggle in high school, especially with math. When I started my university years, or I do remember very vividly that I struggled the first semester. When I went, the timing was part of it. The Iran-Iraq war had just ended the year before. So it ended in 1988, and I went to school 1989. So the country as a whole was facing a lot of effects of that 8-year war. The prime example that affected us was that the textbooks almost were nowhere to be found. So if you were lucky, you knew somebody who had taken this course in prior years, and you would borrow their book or try to get your hands on a book. So that was part of the struggle, that for several of the courses I took in the first semester, I didn't have the books to study. And of course, the transition going from my hometown to now Tehran, a larger city, was part of it. The blessing in disguise in a hardship came to me in a form of an eye problem. So in semester one, I had an eye problem that prevented me from studying. So the university allowed me to drop all of my courses. Had they not allowed me to drop all of my courses on a medical leave, I would have probably flunked and dropped out of university. But that initial experience that I was facing a new challenge helped me when I went back the second semester and registered for many of those courses to do much better. And that was the beginning. And throughout the university, I had several influential professors, some of whom were US educated. So that was one of the reasons that after graduating from the university and working for a number of years, I had this desire to go and experience the other education system. So I came as more of a non-traditional student. So I didn't come immediately after finishing my undergraduate. I had worked for a number of years. So when I came here, I had a family. I had a wife and a young daughter when I came to the US in 1999 and settled in Philadelphia, where I went to school at Villanova University.
And at that time, did you have kind of a research direction? Were you kind of narrowing in on something that you were really interested in?
And when I joined the university, they had received a DARPA grant through a company. I don't remember the name of the company, but it was one of those research-based companies in the area. And the grant was on developing a platform that would deploy sensors in the field and grab these sensors. And my professor, Dr. Ashrafiun, was an expert in robotics and control. So our team, him and me, were in charge of designing the manipulator for it and designing the control system for it. Another group was in charge of the actual motion creation, and Professor Santanam, who I think is currently chair of mechanical engineering at Villanova, his expertise was in shape memory material, and his students, Sudip Bose, the two of them developed an arm. It was a single degree of motion freedom arm that was actuated by shape memory wire. So the arm was there. We were in charge of developing a control system. So that was the beginning of my interest and work, which now is over 20 years working with shape memory materials.
And so with that, what this is kind of going back number, do you remember like where did that additive manufacturing part come in? I know you're kind of materials, you're doing shape memory and kind of a lot of other controls and robotics.
Can I pause for a minute and connect to a charger, and I'll
yeah,
be
yeah.
okay. I am back.
There we go. I can repeat the question. So, do you recall like when did the additive manufacturing part kind of weave into your career in academia?
Yes, I finished in 2001 from Villanova with a master's in mechanical engineering and went to Virginia Tech and worked under supervision of Dr. Ahmadian. And my research ended up being continuation of the work that I had done in shape memory alloy actuation control. Finished my Ph.D. in 2004 and joined the University of Toledo as a young assistant professor. It was exactly 20 years ago in August of 2004. So like any other starting researcher, independent researcher, I was looking for my identity, and part of it was going to be shape memory alloy materials. And I started, because University of Toledo has a medical school, I started looking at medical applications of shape memory materials. And almost every time we would come up with a concept, the bottleneck for us was creating a prototype and testing the prototype. So making the prototype was the bottleneck for us. And most of the time we had to go to a device manufacturer or a contract manufacturer to get us a professional device. And of course, the number of devices we could order were few. We were not in tens or hundreds or thousands that they're used to. So we would be always at the end, at the bottom of the totem pole. So it would take a long, long time to get a device fabricated.
Yep.
So in 2009, 2010, state of Ohio had a program which was under the umbrella of Department of Development of the state of Ohio. At the time, this program, which invested at the universities to expand their research capability, was called the third frontier. So in that time frame, there was an opportunity to apply for one of these grants.
Mm-hmm.
And our university, I was leading our university, partnered with Cleveland Clinic out of Cleveland, NASA Glenn, which is also close to Cleveland, a Case Western Reserve in Cleveland, and a company called Norman Noble. And we got an equipment grant. If I remember correctly, the total size was about $10 million, $3 million for equipment, and then the rest was a match that the institutions had to come up with. So at the university, we got about $600K, and the proposal was on making a nitinol, which is the main shape memory material that is commercialized. Nitinol Commercialization Accelerator. That was the name of the grant. And our goal was to accelerate innovation in this space. So when initially at the time of the proposal, we had the wish list of various pieces of equipment that we would buy once the award arrives. But when we got the award, the two co-PIs and I Dr. Goel and Dr. Baduri. They're in biomechanics and biomaterials. We got together and said, we can always buy smaller pieces of equipment, but with what can we buy with this $600,000 that would put us in a better competitive advantage?
Yep.
And we did research and we got the agreement of the sponsor to buy a 3D printer. But the thinking was, if the bottleneck for device manufacturing out of shape memory for us is prototyping, can we have a device to quickly churn out prototypes? So we went through the process of finding a company that would allow us to put nitinol powder in a printer. It wasn't easy to convince companies to allow for that. I think the only company that was price competitive and allowed user to put new powder in their machine was a company which was relatively small to the big player. It was called, at the time, Phoenix Systems.
Mm-hmm.
So we bought their SLM machine, and later, after this transaction was completed, they were purchased by 3D Systems.
Right.
So our machine officially became a 3D system machine. But once, I guess, the happiness of having the machine got settled in the lab, we realized that what we thought was going to be the research is completely different. So naively on my part, we thought we will just have this printer in our lab and we'll quickly print one device after another. But the reality was nobody had developed process parameters for nickel titanium as an alloy. So our research became on that. So we got a multiple number of awards to focus on process development, and a good few students have dedicated their academic career to developing the process parameters. But that didn't stop us from going in the device direction or application direction. We can discuss about those if we have time.
And what was your impression of the technology at the time? I mean, you wanted to make things faster. I guess it's relative, right? If you're waiting for months for a prototype versus days or whatever it may be. But did you have a opinion on the technology as you started investing in it, or investing in the lab research and things like that?
Yeah, so I didn't know anything about 3D printing or additive manufacturing. I had not taken any class in it, going through engineering school. It was just the hype at the time. The way we did our homework to find the right technology for us was to go out and review all the technology that was available and we thought would be relevant to developing nickel titanium. And like any other professor probably would do, we got the results of our research and submitted it as a review paper. And I think this is the highest cited article that I have ever written. The intention was not to write a paper. The intention was to just compile all the technology available, so to choose the right printer for us. But the impression I had was, as I said, and you also summarized well, that we thought this would be the solution to all of our problems. We, in the sense that we knew, for example, if you wanted to get a device functional, you had to do shape setting. And making a shape setting mandrel requires extensive machining and having a specialized heat treatment furnaces and so on and so forth. Our idea was we will arrive at a recipe that would get us to print parts in the functional form. So we would save all of those steps of various type of machining. Typically, it's parts that we were interested in were of course, that you get the semi-finished blank, like a wire or a tube or a sheet, and then you do processing like laser cutting, and then that's part of the process. You have to repeatedly do levels of heat treatment, mechanical treatment, heat treatment, mechanical treatment, heat treatment, and it still is a more of an art than a science to get a part functional. So our thinking was, we don't have to do any of these. We'll just print parts, and we will get to test and see a lot of these applications that we had in mind come to fruition.
Yeah. And what were as students started to learn about kind of the technology, were you seeing interest more broadly in additive? Were they coming to you for kind of just kind of more broad engineering kind of focuses, or was there like a trend to say, okay, hey, this is kind of the it thing in manufacturing, engineering, whatever it may be, there's kind of an upswell? What was
Right.
that like at the time?
Definitely. So it changed the trajectory of my lab completely. Even though, as I said, the initial rosy image that we had in mind didn't quickly materialize, but it was the beginning of many students showing interest in our lab. Over time, we have had a lot of quality students who came through our labs and became very successful. So shape memory and it's being a different material with distinct properties, have an attraction. But when additive manufacturing was added to it, definitely the interest was significantly more. And because the students who completed work in our lab were also pioneering a technology, a know-how, and also in certain materials, they had a very good success rate in getting industry as well as academic jobs. So definitely a change in direction and a new beginning for our labs.
And I've never asked a professor this, but as you get, because I went through a PhD program as well, I went more on the industry side, but as you are advising students and graduate students, kind of what's your advice, or kind of as you mentor them, kind of as they're making this decision, right, in terms of either staying on as a postdoc going towards the professor track, or kind of looking at industry? Do you have kind of advice that you give them from your own career, or things that you've seen kind of other successful students kind of pursue?
Yeah, one thing that I try to emphasize to the students is that uh, regardless of the direction you take, either academia or industry, or maybe even working for the government at one of the national labs or agencies, it's very important to keep a healthy perspective on life. So I have had students who at the time of studying either were couples, so husband and wife working in my lab, or then later on married and became lab mates in the lab. And it would happen that one would graduate and would have a prospect of going to a place while the partner was in back in Toledo, or they would get job offers at two different institutions that were a few hours of flight apart. And sometimes they would just accept the offers and go away and do it. Sometimes they would ask me, and anytime they ask me, I would repeat this advice. Probably some of them memorize it. I said, nobody has given you a guarantee in life that you would live for this many years. So then you will go through this transition period that you're perceiving this would be only for a few years, and eventually we'll find a job together in another town and be together. I said, nobody has given you guaranteed that both of you are going to live for that many years to be together. So life is so precious, and being in a meaningful relationship is as important, if not more important, of your academic career or your job or your position. So I would also try to practice this myself, not be or at least I don't think I ever was a workaholic that would put work and success in my career ahead of everything that I had otherwise in life. So that was a style, and I would prioritize success of students ahead of essentially my research agenda. Just again, if so happened that uh, there was a life situation, a student could not work or had to pause research or had to leave, I would not insist that no, 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 it's more important that my research agenda goes forward. So I would always put people first, in this case, the students first. And I don't think I have lost or fallen behind because of this practice. And I hope I have taught my students something in the process. I genuinely believe there is no professional success that justifies um, putting your life on hold. Of course, you have to work hard, but I think keeping a balance is doable and should be practiced.
Great advice and great perspective. Um, as you think about kind of we've talked about the kind of looking back at a lot of your kind of early starts of the research and things like that. Kind of speaking of today, what are some of the things that you're focused on or you're excited about as a group or the industry, and whether it's additive or not?
Sure. So as we moved along the journey of additive manufacturing, we always kept the focus on shape memory material, even though shape memory material is a fairly niche market for additive. Because of the interest, we kept it. We didn't try to expand to other alloys or other materials. Rather, we decided to go deeper instead of wider. So as opportunities for funding came along, we invested in other ways of producing nitinol. We also invested in going after other alloys of shape memory, such as nickel titanium hafnium. I think our group was the first ever that processed an alloy of nickel titanium, a couple of alloys of nickel titanium hafnium. We also always also invested in modeling aspects of additive manufacturing of these alloys. We invested more recently in alloy making. So we brought one of the amazement devices to the laboratory that allows us to create small quantity of the alloys that expedites the process for us. Prior to this, especially if we wanted to try a new composition, we had to wait months for somebody to melt the alloy and atomize and sieve and all of this. Now we have the ability to go quickly from a composition to a small amount of powder which we can test. And the credit for investing in this goes to Dr. Purganji, who is now at Nikon SLM Solutions. He was and still is a research professor at the University of Toledo, and his recommendation was to invest in one of these machines. So, and also our group has recently gone after binder jetting of this alloy, direct energy deposition of the same material. And that allows us to be a center of excellence when it comes to additive manufacturing of shape memory materials. We have a lot of companies who come to us for advice, or if a company wants to invest in one of these technologies to go after processing nickel titanium and similar alloys, they come to us. It also has allowed us to support innovation and startup companies who try, some of them by my own students, to try to get involved in um, application side of additive manufacturing of nickel titanium.
And so as you think about it, and I think one of the efforts of this podcast is to kind of inspire that next generation, what piece of advice would you give to folks in 2024, kind of late summer, thinking about careers in manufacturing and additive or materials or mechanical engineering, um, is there, would you say stay away, or is it something that like is there still a lot of upside, a lot of potential, a lot of opportunities out there?
There is definitely a lot of opportunities in this space. If you look at various calls for proposals that are coming out these days, the geopolitical facts all point to the direction of reshoring, more of manufacturing coming to the US. But the reality is the difference in cost of labor at other countries and this country. Uh, all of these and many other technological advances all push us in the direction of going to digital manufacturing, more advanced manufacturing as opposed to labor intensive manufacturing. And this in turn creates a lot of opportunities for someone who is at the university. The opportunities exist first for workforce development. At various levels of workforce development, there is a significant need. All the employers are looking for qualified engineers who have expertise in manufacturing, expertise in advanced manufacturing, expertise in AI, expertise in modeling, digital twin as an incarnation. So there is a lot of interest at various levels, from technicians to holders of bachelor's degrees, master's degrees, Ph.D s. All the indications is that this is going to grow. And along with that, for meaningful training of workforce and also to solve technological problems, there is a need that is substantial in research. And I see more and more as the common thread, AI being a required part of the research, or some level of AI involvement from the design aspect, to process optimization, to material selection, to material design, to manufacturing optimization. The expectation is there would be meaningful tools and capabilities and technologies that would come out of this um, activities, and will make manufacturing more affordable yet again, and doable in this side of the world.
So last question. I've been asking this to a lot of folks. So what, is there a piece of writing, a book, could be a movie, it could be a podcast, it could be whatever, that kind of inspired you on your career that you'd like to share with the audience?
There is one book that is ironically not technical, that I think has had the most profound on on shaping my character, and that was the audience can look up the book. I unfortunately don't remember the name of the author, but it's in the self-help, self-development category. I think the title, if I'm not mistaken, is Feeling Better. But the essence of the book, and I read this more than about 30 years ago, and I've gone to it a few times. It was more or less a psychology book that helped the audience in reframing the realities of life, the things that would naturally worry us, put us in a difficult spot, a dark spot sometimes. But the art of this book was, as I said, to reframe various situations and systematically allow you to analyze things that appear to be very difficult, very life-changing, to see that no, they're not as important or as dark or as insurmountable of an obstacle that you may think. And it also advocated keeping a positive attitude even in the face of difficulties. So that's a book that I think was very influential, even though it's not a technical book.
Fantastic. Well, thank you so much for joining the show today. We'll look forward to kind of hearing more about your work, seeing you around the various conferences, and continue to be a big part of the industry. So thank you so much.
Thank you, Mike. I enjoyed the conversation.